Welcome to another TwinCAT Connectivity webinar. My name is Sven Goldstein and I'm Product Manager for our automation software TwinCAT, especially everything regarding connectivity. In this webinar, I would like to show you how to connect industrial controllers to the cloud service AWS IoT SiteWise. And should you have any questions during the webinar, please make use of the question window that is part of the GoToWebinar software. We will try to answer as many questions as possible during the webinar or after the webinar via email. So before we dive into AWS IoT SiteWise, let's have a quick look at our back of IoT product history. Everything actually started in the year 2012 when we developed the first connectivity prototype that was able to publish data streams from one of our controllers to the cloud. A few years later, in 2014, we showed how to run a TwinCAT 3 engineering environment based on a virtual machine in the cloud. And we already made the first steps into implementing a common base for our connectivity products. And in 2015, this implementation resulted in a new connectivity product family called TwinCAT IoT. With TwinCAT IoT, our users can establish a secure and bidirectional data communication between a TwinCAT device and a cloud service. And I think it's important to understand that we do not force our customers to use a specific cloud service provider because we want to keep our openness and our open ecosystem. And in the end, this is a trust relationship that our customers have to make. So over the years, more and more communication protocols have been added to TwinCAT IoT. And right now, we have support for the protocols MQTT version 3, MQTT version 5, HTTPS, WebSockets, OPC UA PubSub, and OCPP. So let's have a look at AWS IoT SiteWise. What is AWS IoT SiteWise? AWS IoT SiteWise is a cloud service offering by Amazon Web Services that lets you collect, organize, and analyze data from industrial equipment, which basically means that SiteWise provides different mechanisms for the data ingest and a common platform to structure the data and forward the data to other cloud services, for example, to analyze the data. And during this webinar, we will have a closer look at what this actually means and how this may look like for your project. So from our point of view, everything starts with the data ingest, right? Because with TwinCAT IoT, we want to connect our back of controllers to AWS IoT SiteWise, for example, to publish some I/O data points. One of the connectivity options to AWS IoT SiteWise is an MQTT connection between TwinCAT and the cloud service AWS IoT Core, which is basically a managed MQTT message broker on the AWS cloud. So for this kind of connection, we can use one of our TwinCAT IoT products, which is called TF6701, which is an MQTT driver for the real-time, and which can then establish a secure MQTT connection directly to that cloud service. On AWS IoT Core, you can configure a so-called IoT rule, which will then forward the incoming data streams to AWS IoT SiteWise. Another connectivity option for the data ingest would be to use OPC UA. By using the TwinCAT OPC UA Server, you can make data points from the TwinCAT PLC real-time available via OPC UA. And by using a back-of-edge device together with the software AWS IoT Greengrass, you can make use of the so-called AWS IoT SiteWise Edge Gateway. The Edge Gateway connects to the TwinCAT OPC UA server in order to collect the data points and then publishes those data points to the AWS IoT SiteWise service in the cloud. I think it's important to understand that you can also combine the edge device and the controller into one single device. With the new operating system, TwinCAT BSD, you can run both AWS IoT Greengrass and the TwinCAT PLC Realtime and the TwinCAT OPC UA server on the same device. In this case, you would run the SiteWise Edge Gateway in a Docker container together with AWS IoT Greengrass, and the TwinCAT PLC Realtime and the TwinCAT OPC UA server would run on the host system, as you can see here on the right hand side. So to get a better understanding of how the data ingest workflow actually works and what the different configuration parts are, let us have a look at a demo architecture that I have set up here in my test environment. So this architecture may or may not fit everyone's requirements, but I think it clearly shows how flexible and powerful the TwinCAT 3 software is, especially when it comes to the different connectivity options. So let's assume that we have a retrofit scenario with 3 existing TwinCAT PSC devices. Each device represents a water heater, and we want to acquire some data from this water heater and publish those data points to AWS IoT SiteWise. All devices run the TwinCAT PSC real-time, and we also have some I/O data points attached via an underlying field bus. Well, I haven't really focused here on the field bus here in this picture, so I just want to focus on the PSC. So we have just learned that there are different data ingest options, and I would like to show you an approach which is based on OPC UA. So first of all, we need to make the data points from our 3 boiler devices available via OPC UA, right? So in my scenario, I decided to aggregate the data points into one single TwinCAT OPC UA server, and that OPC UA server should run in our TwinCAT Cloud Engineering environment, but it can, of course, also be applied to any kind of virtual machine. So to connect the server with the 3 TwinCAT PSC devices, I decided to use ADS-over-MQTT because, first of all, an MQTT message broker is part of every TwinCAT Cloud Engineering instance, and for simplicity reasons, it is not shown here in this picture. And second, it can also easily be configured without changing the PSC code of my existing devices because, hey, we're in a retrofit scenario, right? We do not want to make changes to the existing TwinCAT projects or to the existing PSC code. And ADS-over-MQTT can be configured on top of an existing TwinCAT project without having to change anything. So now that we have connected our 3 TwinCAT devices with a central TwinCAT OPC UA server, I want to make the data points from each device available via OPC UA, right? And I do so by channelizing everything through the TwinCAT OPC UA server. And we have learned on one of the previous slides that we need the AWS IoT SiteWise Edge Gateway to collect data points via OPC UA and stream their data values to SiteWise. In my environment here, I have used an Amazon EC2 instance, so basically a virtual machine, and that Amazon EC2 instance hosts the IoT Greengrass and also the IoT SiteWise Edge Gateway. So let's have a look at the TwinCAT PSC project and the TwinCAT OPC UA server that run on TwinCAT Cloud Engineering. One thing that I haven't mentioned before is that I also use a TwinCAT PSC runtime in the cloud in order to aggregate the data points and maybe do some further modifications on them. So for example, to do some pre-processing like calculating averages or something. So this is how the data is structured in that project. So on the left-hand side, you see that we have one TwinCAT project with 3 PSC projects, one for each device, right? Boiler 1, Boiler 2, Boiler 3. And each PSC project has a global variable list, which is called SiteWise. And in that global variable list, the OPC UA data points are defined and also shared with the OPC UA server by using this attribute opc.ua.da. So the TwinCAT OPC UA server then provides this global variable list in a folder for each corresponding device, which means you see that there are 3 different namespaces here on the TwinCAT OPC UA server, Boiler 1, Boiler 2, Boiler 3, and each namespace has this global variable list called SiteWise here with the variables that have been defined in that global variable list. The server itself is also reachable on a secure endpoint, meaning the basic 256 SHA-256 sign and encrypt endpoint on the public IP address from the TwinCAT Cloud Engineering instance. So now that we have our data points available via OPC UA, we can focus on the SiteWise configuration. As I mentioned earlier, SiteWise allows to define a hierarchical information model from which you can then create assets. So applied to our example, that means that we want to create, first of all, a model for our boiler park, right? Because we have different boilers and we need to organize them somehow into a boiler fleet or a boiler park. And we need a model for the boiler itself. And we need a model for the water input pipe that is attached to a boiler. So this is just a definition that I made. Of course, you can also say that the water input pipe is part of the boiler model itself, but I just wanted to create an additional model for it. So each model defines two things. First of all, attributes, which is static metadata, right, which does not change during the runtime of an asset. And the model also defines measurements, which represent live data from an asset. So measurement could be the current fill level of the boiler, or the measurement could be the water consumption rate, something like this. So after we have created the information model, we can create assets from each model. So in our example, this means that we have one asset that represents the boiler park, the fleet of boilers, right? And we have three assets that represent our three boilers, boiler 1, boiler 2, boiler 3. And we have three assets that represent the input pipes attached to the three boilers, pipe 1, pipe 2, and pipe 3. So now that we have the assets, we need to create a mapping between each measurement and an OPC UA data point, because we want to have live data coming in for each boiler, for each measurement of a boiler. So we need to create a mapping, right? So we can, on AWS IoT SiteWise, we can define which measurement is mapped to a specific OPC UA data point here. So this is how the configuration may look like on AWS IoT SiteWise, meaning on the management console of Amazon Web Services. So you can see here the configuration of the boiler park model with the attribute definitions. You can also get insight here on the measurement definitions. You can also do some transformations of the data. So different options here. This is the model for the boiler itself. So you see the measurement definitions highlighted here in this screenshot. You can also see assets that have been created from this specific model. And we have the model for the water input pipe. So you also have on the management console, you also have a view on the assets themselves. So after you have created them, you can see that there is one asset for the boiler park, and there are three assets below that boiler park asset: boiler 1, boiler 2, boiler 3, with their corresponding water input pipes. So earlier I talked about creating a mapping between the measurements and actual OPC UA data points, and this is where that happens. So you actually specify for each measurement what the browse name, the browse path is to the corresponding variable on the OPC UA server, and you also see here the latest value that has been received from the data collection, from the OPC UA data collection, together with the corresponding timestamp. So you see all this here on the management console, which is nice because you can easily see if the data is collected or not collected, right? So it's a good place to see if data is coming in. Okay, so now that we have our data available on AWS IoT SiteWise, the question is, what can we do with the data? So now, I mean, it's good that we see the data in this tabular overview and see the latest value, but is that everything, or can we do something else? So I would like to show you some possible options. The first thing you can do with the data is to display it on a web-based dashboard, which can be done by using AWS IoT SiteWise Monitor. And IoT SiteWise Monitor connects to the data points from IoT SiteWise and lets you create dashboards and also share those dashboards with other users. So how could this look like? The dashboard itself can be accessed by using a regular web browser, and this is just an example here. So this is how it could look like for one of our boilers. So you can see different graphs, different controls for each measurement, and you can also see the static metadata, meaning the attributes for this particular boiler here. So you can see, for example, that the controller type from that particular boiler is a CX8190. You can see that the manufacturer is Backoff Automation. And you also see the live data here from the measurements, the current fill level, and another measurement called drained water per operation. And you see this here all this in an HTML5 based dashboard. You can also filter the time range that you want to display the data values for, and you can, using here the navigation bar, you can also share this dashboard with other users. So another option could be to make use of the different analytics cloud services that AWS has to offer. So first of all, you could store the data point values in an Amazon S3 object storage and then run an AWS IoT Analytics query on the data in order to maybe select a specific time range or only a specific subset of your data points. And the resulting data set can then be used on Amazon SageMaker to further analyze the data. Such a query could look like this. So here in this sample query, I have selected only data point values from a specific day, meaning from December 11th, 2022. And I also wanted to include the metadata from this asset in my query. So, and this is the resulting data set that I get as a result. So it's in CSV format. You can download it directly here in order to maybe analyze it in Excel or something. But you can also use this query here to forward the data to an AWS IoT Analytics notebook. And then the data is streamed to that notebook on SageMaker, where you can then process the data and run further analysis on it. Here in this screenshot, I use a Python script to connect to the data set, convert it or typecast it into a CSV format here. And from this point on, I can use all the tools and modules on my data that AWS IoT Analytics has to offer. So before we finish this webinar, let me give you some tips and recommendations that you may find helpful. Just as with any other system or system architecture, there are things that I wish someone would have told me before I started work on it. So when I first started with AWS IoT SiteWise, I just followed their getting started guidelines. But I immediately wanted to adapt their use case to my own use case, which means I started with my own OPC UA server instead of their sample server. I created my own data points with my own information model and so on. So, and of course, I ran into problems, right? So as an example, I wanted to display my data point values on the IoT SiteWise monitor, but everything I got was the message, no data. There is no data to display for this time range. So I started debugging my architecture step by step. And well, in Germany, we like to say, let's take the engineer's approach. So I checked the typical stuff because my TwinCAT OPC UA server is running on a cloud engineering instance. I first of all checked, is the TwinCAT Cloud Engineering instance online? Then I checked if the TwinCAT 7-day trial license that I used, if it is still valid. Then I checked if my TwinCAT OPC UA server is still online and if it still delivers data. So I connected another OPC UA client to my server, subscribed to the data points from my global variable list, right? And just checked if there is data coming in. And that was the case. So everything was fine. TwinCAT was running, the cloud engineering instance was up and running, the license was still valid, the server was providing data. Everything seemed to be perfect from a TwinCAT point of view. So it had to be something on the edge gateway, meaning on my EC2 instance with the IoT Greengrass, right? And it took me a while and several blog posts until I figured out the important places where to look for further debugging information. So the best source for debugging really is the log file collection on IoT Greengrass, in particular the Edge Gateway log files. Of course, you can stream and mirror the log files to AWS CloudWatch, but this is the location where they originate from on IoT Greengrass. So for my no data scenario, there are actually two log files that help me finding the root cause of the issue. So first of all, the OPC UA collector log includes information about the OPC UA connection between the Edge Gateway and the OPC UA server. And the publisher log includes information about the connection between the Edge Gateway and the IoT SiteWise service, meaning the cloud side of the communication. So the OPC UA collector log, that was the first thing I checked, right? And it showed that everything was fine. So an OPC UA connection to the server was established. So the client successfully connected to the server. The data points were subscribed and also data values were coming in. So everything seemed to be perfect on the OPC UA level. Okay. So then I checked the publisher log, and this log file instead contained a very useful hint. And there was a message that said, throttling exception, you've reached the maximum rate of batch put asset property value entries ingested per asset property data stream. So I was wondering, okay, well, what does that mean, right? But the kind of exception here, the throttling exception, gave me a very useful hint because it said, well, I thought it had to be something with service quotas, right? So because some of the services on AWS have service quotas, so I checked the website for the service quota limit for AWS IoT SiteWise, and I found an entry here that said that the number of batch put asset property value entries ingested per second per asset property per region per AWS account is 10 entries per asset property. So, which means I just hit that limit, right? So, what did I do? So, because it seems that my setup just reached that particular limit, I just reduced the sampling rate between the Edge gateway and the TwinCAT OPC UA server, which was simply a setting on the Edge gateway itself, right? And then I restarted everything and everything was running fine. Data was coming in. I could see the data on my SiteWise monitor and everything was fine. So at this point, I would like to thank you for watching this webinar, and I surely hope that the provided information will give you some new ideas for solving your daily challenges. Thank you, everyone, and have a great day.